So basically, you will see how you can download the VPN software. Have you guys tried this process before? I believe if you guys run research assistant, you have a device here and you want to work from home and access your device here, you have to do this step. That's how I do it. You have to activate the VPN first, and then you can do remote connection. So that's the first step. Second step is to get the Citrix software, and you look on the Citrix software. So you follow the steps that you have here, like log into Citrix apps. And once you finish this process here, like it's gonna tell you if you want to install it for Windows or Mac. So you follow the steps here, and at the end, you are gonna have the Citrix app on your device. And it's gonna be something like this. Let me see if I have Citrix. I believe it's this one. If you are on campus, I believe you don't have to do the VPN. If you are out of campus, you have to do the VPN. So once you get to the Citrix, it's going to be like a window like this. And then you go to the apps and you will find all the softwares that licensed by the College of Engineering. And we need the ArcMap one. Once you click on ArcMap, and if you are logged in with your FIU account, it's going to open into your device like a normal window. Okay, so that's how we can do the ARC mapping. But from my experience from when I taught this class 2 years ago, students said that ArcMap through Citrix is very, very slow. So if it's very, very slow, maybe you look for a version that you can install it on your computer, not through Citrix. So just try it, or maybe you can just use ArcGIS Pro, and I'm gonna show you how to install it. For ArcGIS Pro, it's gonna be something like this. You will go here on Google and search ArcGIS Pro FIU, and then you will go to the center, the GIS center or the FIU GIS center. And when you get to this center, you will find a steps or how to download the software, how to access the software, how you use your FIU account to do the whole thing. Okay, so that's how you get this two software. Okay. As a FIU student, you have access to ArcGIS Online and have access to ArcGIS Pro. So you will be able to download the software, you will be able to access without Citrix. Okay, so ArcMap is going to be through Citrix. ArcGIS Pro is through the FIU GIS Center. Okay, so let's say that you guys spent today trying to download this software, and they are very, very important software. Why? Because as a catastrophe modeler, you have to have GIS expertise. And then some people are GIS developers. They will say, oh, I'm a structural engineer, or why would I do this? No, you have to do this. Like if you want to be in that field, you need to be able to do processing in GIS, handle GIS files. Okay, so we are going to see how the GIS working, but what I want to tell, it's really, really important to know this stuff about GIS if you want to get into this field. Okay, so let's say that you guys were able to download the softwares. So the software, once you download it, either through Citrix or either you install it in your computer, you just click the icon. And once you click it, it's going to be a window like this. Okay, so this window, that's your workspace. That's where you have all the maps of the community, of the city, of the county that you're working on. Is going to be here in this white window. It's not going to be wide, but this is because we started from plan. Here on this window, you are going to have all the layers. Like if you guys work on AutoCAD, AutoCAD has a lot of layers. So you have a layer for the walls, layer for the reinforcement. Same thing when we do maps. You will have different layers, like layers for base map that shows how the geography look like. You will have maybe digital elevation map. You will have land use map. You will have buildings map, infrastructure map, all these layers on top of each other. You will be able to manipulate these layers from here. To access the layer, zoom to the layer, adjust the layer, visualize the layer. You will be able to do everything from here. Here, you are going to have multiple of stuff. Like you can make, like, can you see, like, there's 3 tabs over there. There's one is called Arc, Toolbox, Catalog, Search. So this is when you have tools and you want to navigate these tools. Like you want to do some processes on the GIS layer. you want to extract data, you want to import data, you want to project data, because right now we are dealing with geography, and we know that the Earth is a sphere, so there's projections. Like when it's a sphere, we're trying to project it into a map, so there's lots of projections that we are going to deal with. Maybe we define projections, or we transform projections. So all these stuff, we're not going to get into details on these, but that's what the toolboxes do. Toolboxes do lots of analyses on the shape files that we're going to know in a little bit. Okay, so let's say we open the ArcGIS and it starts to be something like this. So the first thing that I need you to know before doing any GIS analysis, there is something called shape files. So shape files is the language that the GIS analysts uses to communicate with each other. So it's a kind of like a way to store data. So you guys have been working with Excel, right? Excel is one way that we can handle data. Every row is going to have a data about something. Let's say about like we are going to make an Excel sheet that has the name of each one of us and a lot of details about each other. Our age, our height, our weight, everything. So Excel is one way to do it. But the thing is, ArcGIS can handle Excel files, but it's a much better. It uses other formats. It's used the format that is best that matching with GIS is the shape file. So the shape file is kind of like something like Excel, has data, but also has the latitude and longitude of every data that you have, because since we are dealing with geographical information systems, so it's something about the position of the data. So let's say that we are handling buildings. So for buildings, we are looking for what is the X and Y of this building. What is the type of this building? What is everything about this building? So let's see how this looks like. All right, so all right, so right now I'm gonna give you all the data that I'm gonna work on today. I'm gonna provide you with a Google Drive that has this data. So right now I have there's a county in Texas. It's called Galveston County. So Galveston County, I have the building polygons about this county. So the building, usually the data file is something like this. Like all these are the data file with different formats. Like there's a shape file format, there's a database format, there's a projection format. We need all these files so we can load them on GIS. So if you lost one of them, like let's say that you lost the projection. You lost the projection when you load the data, like let's say I deleted the projection from here. So when I load the data in ArcGIS, it might be loaded, I don't know, in Russia or something, not in the US. So every file of these is important. But when I load the files on ArcGIS, by the way, like when you open ArcGIS, is going to ask you if you want to open a file that you already worked on before, or you need a new one. So what I'm going to say, I need a new file. So when you say that you want a new file, I want to start with a blank map, like something that is new, and I'm going to start from scratch. So you either can load the data from here. There's something that's called add data. So I'm going to click and add data. Or basically, all what you're going to do is you can drop this file, the shape file, the one that's called AutoCAD shape source. I can drag and drop, and I look for ArcGIS, and then I can drop it here. That's also a one way to do it. So it takes a little bit, some time. And this is actually all the buildings, not in Galveston County. This is actually the Galveston Island. The county is big, and this is island on the county. But it will tell me I can't see anything. Like it's just like a bunch of gray lines. This is because that's hundreds of buildings, or thousands of buildings actually. I believe like 25,000 or something. If I zoom in, so things is gonna start to be clear. Like I'm gonna zoom, and then I'm gonna see the polygons of the buildings. So that's actually every one of these polygons is a building on the Galveston Island. So let's make this in a better visualization. We always need, or it's better to have a base map under these buildings so that we can imagine where these buildings at. So what I would do is I would go here at the data where I added the data. When you add data, like the same way, rather than drag and drop, if I click add data, you go to where your file at, and you click the file and then say add, it's gonna do the same thing, like the same way that we did add and drop. All right, so let's say we added the data. The second thing, I'm gonna add something is called base map. So base map, the arc map is gonna give you options. What kind of base maps that you want? Do you want a street base map, topographic? I'm gonna say a 1D imagery base map or imagery with label. It's gonna be look like the Google Earth thing. So once you add the base map, it's gonna be underneath these buildings, and then you are gonna see where actually these buildings is located. So it's gonna take a little bit of time and make sure that you are connected to the internet, okay? All right, so it says that here that the following data sources use geographic coordinate system that is different. Okay, so it says that the world imagery is GCS. So that means like the two projections are a little bit different. The base map is different a little bit from the shapefile that we have. And we are going to talk about the projections in a little bit, but let's see how this community look like. So I zoomed out. If you want to zoom out and make a full view. All right, so if I full extent of the data, oh, that's full extent of the base map. All right, you can right click on the shapefile here and you can say zoom to the layer. So when you click on the shapefile and zoom to the layer, it's gonna show you all the buildings that are included in this layer. So actually my buildings are here, but I have to zoom in to see them. And that's actually where is Galveston Island, and this is the Galveston County over there. We got this? All right, so that's the shapefile. But you can ask me a really valid question. You will tell me who created the shapefiles. Like, how can I make the shapefiles actually, or how can I get them? Well, counties or maybe in the past, they would make the shapefiles manually. Like you would like go through building by building and try to create them, draw them manually. However, recently, like a few years ago, like with artificial intelligence and image processing, they would use like the images that we have and they process them and they create the shape files with image processing. So you don't have to create these millions or hundreds of buildings. But you are going to have just polygons of them, and they start to improve their accuracies by improving the technology itself. And there's something called Microsoft Building Inventory or Bing Maps. They provide building footprint for the entire US. So we have building footprint for the entire US. But the thing is, it's not only about the building footprint. Like, it's not only about that you just draw a polygon. We need data about this polygon. Like the thing is, machine learning cannot do that. Like machine learning can only process the image, but cannot understand if this is a residential or commercial or 1-story or 2-story or all the other information that we need about this building. So all these data has to be entered manually. So there's data entry people that they would enter this data, okay? So let's say we are not going to talk about where this data were developed. We always get this data ready that we can use so that we can do analysis with this data, right? Does anybody have any questions so far? Okay. So let's see what is inside this shapefile. I'm going to zoom in on maybe in a few buildings here in this busy area. So here is the zoom in tools. You can zoom in or zoom out, or you can pan, like move, or you can show the full extent of the maps. Also, maybe I'm gonna zoom in on this residential block. It depends on your internet, so it might take a little bit of time to zoom in and zoom out, but I believe if you have the base map off, it's gonna take less time. So, right, maybe I'm gonna turn this off. All right. All right, so there's something here that has like the blue circle here with I in the middle. It's called the identity. Like if you click on this and click on any building, it's gonna give you all the information that we have about this building inside the shapefile. So they will tell you this building has FID this, and shape is polygon, and object ID, parcel ID, shape lanes, X and Y coordinate, parcel ID, building area, number of stories, building value, property use, occupancy, foundation type, number of units. It's going to give you all the information that he has about this building. Click on another one, you are going to get different information. So that's how you know the information about just one building. You just have to click on this building. And also, so you guys, for your information, all right, so this is how the US, the geographic system of the US look like. You have building, and the building is part of something called census block. And the census block is part of, well, let's start again. Building is like the building is the building itself, just this area. That's called building, or the built area. But your land that you own a home on, it's called parcel. Okay, so like if I show up the base map again, so the whole area, it's called the parcel of your land that has your whole building in it, like from here to here. That's your property. So your built area and your parcel is yours, okay? So we have a building, and then the building, there's a parcel, and then the parcel, there is a census block, and from the census block, there's something called census tract, and then there is a county, and then there is a state. So this is how the geographic data look like. So sometimes actually, some counties, they don't have information about the building. They have information about the whole parcel. They will tell you, oh, this parcel is a residential parcel, and it has this, and this information. So what we do, we lay out the building footprint, and the footprint doesn't have any information. Like if I click on any of the buildings here, let's disactivate the base map. If I click on any of these buildings, they don't have any information. But if I click on the parcel, it's another polygon, it has a lot of information. So with some GIS analysis, I can transfer all the data from the parcel to the building. So basically I tell GIS, how about if you join the data from with the shapefile from the parcel and the shapefile from the building, if the building is within the parcel. So basically it runs like a for loop inside. And if GIS found the building are within the polygon of the parcel, is going to transfer all the data to the building polygon. So that's one way to do it. Okay. So I told you about if I want to access a data about a specific building. But what if I want to know, or I want to see all the data inside the whole shapefile? So you basically come to the shapefile here in the layer and right click, and there's something is called open attribute table. So let's see how does this attribute table look like. So actually this attribute table, you can put it in a different ways. Like you can take it out like something like this. I usually put it down there. You can actually make it big, like huge like this to get the whole screen so you can have access to all the data inside the shapefile. If you look at this, that's the shapefile itself. It's like an Excel sheet. Excel sheet has a column and has an object ID. And then there's a parcel ID. Every parcel in the US has an ID. This ID never changes. Every parcel has an ID. And every building has an ID, I believe so. So, and then you will have the shape lengths, the shape area, like the area and the perimeter of the shape file of the shape file of the building, and the latitude and longitude, the building area, the I don't know, a lot of information, occupancy, foundation type, number of units, F archetype. This is the stuff that I added after. Like from here, that's all the stuff that I added to the shapefile, and that's what I'm going to talk about next. All right. So let's say that you were provided with all these information, but there's some information that's not there, and you want to add to this information, or you want to edit some of these information. Like let's say that you find out that this building is not right, or there's a building that is not there, and you want to add it to the shapefile. So that's the stuff that we are going to learn right now. Okay, so let me minimize this screen and put it back down here, or maybe close it for now. So let's say that we want to edit this shapefile, okay? So to edit this shape file, you will go to editor and you say, I want to start editing here. If you didn't find the editor tool, you go to customize, toolbars, and check the editor toolbar. So it's gonna show up and you can put it anywhere. All right, let's say that you have the editor outside. So I'm gonna click editor and I'm gonna start editing. All right, so when you say start editing, there's many things that I can do. Like I can draw a polygons from scratch. You can edit the attributes. Like when I click, like let's say I want to draw a building from scratch. So I'm gonna come here and there's something it's called create feature. Every building here is a feature. Okay, that's called features. If it's a polygon, if it's a point, if it's a line, GIS define them as a feature. So if you want to create a new feature, it means like when I add more polygons, you are going to click to create features. So let's say I clicked on create features. Here, all the shape files that you loaded, like maybe I loaded 10 shape files here, they are going to show up here. And it's going to ask me which shape file that I want to edit. So I only have one. So if I click on this one, like this, it's going to show up down here what construction tools that I want to use. Like, do you want to use a polygon? Do you want to use a rectangle, circle, ellipse? So maybe I'm going to use something like polygon. So I'm going to like here, once I click on it, I can make something like this, this. And once I finish, I right click and say finish part or finish sketch. So once I finish a sketch, I have a new building added, but this building doesn't have any information. Like I just created this building. All right, once I finish, I can like escape the straight segment like here and get back to this edit tool. So once I get back to it, like I can click on this building or something, right? Or I can click on this building or whatever building that I want. If I want to draw back again, I go back to the reconstruction tool, the construction tool, and start drawing again. But let's say that you don't want to draw a new building. Let's say that you want to edit information. If you want to edit information, there's something here. It's called attributes. So once you click on attributes, like let's just say I'm going to click here on this building, all the attributes, every information about the building, it's called an attribute. So there is a feature and there's an attribute. The feature is the geometry. The attributes is the data. So for the attributes, all the attributes are shown here. What if I found out sometimes building says it's residential, but it's not residential, it's a gas station. And I want to change this from residential to a gas station. So you basically come here and it change the use of this building and write something else, right? Let's click on the building that we just created. Like, let's click on this one. There is no data inside. Why? Because I just drew the building. So once you do the building, you start to add all these data again, right? So that happens, I didn't do that much. Like I didn't do that I had to draw buildings from scratch. Maybe in a community that already provided the data, while I'm navigating this community, I found that some buildings are not there. So, but I don't have to draw the whole community, maybe 1, 2, 3, a few parts of the community, okay? So that's one thing to do this stuff. But all what I can say is sometimes I get provided some data and I have to do some work to get more data. I will tell you one of my experience. I was studying, for example, the thing is we have a community. This community is called Mexico Beach, Florida. It's like in the far north of Florida, like very close to Tallahassee. This community got hit with Hurricane Michael in 2018. And Hurricane Michael wiped almost all of the community. So the thing is, we have some data about this community, but we need to record damage data. So I have all the information about this community, but I need to add more fields. Like I need to add damage assessment field. Like I need to add a field for the damage assessment of the windows, the doors, the foundation, everything. So I have to create new columns or new attributes. And I have to go through the community building by building so I can enter this information, right? So, for example, that's actually how I used to do it. Like basically I go to Google Maps, and I'm gonna search Mex Beach, Florida. All right. So this is the location of Mexico Beach, Florida. Somewhere here. Hurricane Michael goes all the way from here and hit this community. Okay, let's zoom in. All right, let's see how this community look like right now. If you look, I believe the community is still recovering even after, I don't know, like 7 years from the hurricane. So let's see, how did I collect the data? So what I'm gonna do, I'm gonna take this cruiser and I'm gonna throw it in the street, like maybe somewhere here. All right, so all right. So look at this map. You will see that there is nothing here. Like the community looks great. There's nothing with it. So, but the thing is, this map from June 2023. So let's go back in time and see how this community looked like a few years ago. So in some communities, there is something here that's called see more dates. So see more dates, you can access information from November 2017 and see how this community looked like. And maybe here in May 2011, here's in 18. Look, sounds like there wasn't much here, but let's actually look at these buildings. Yeah, look at these buildings. Maybe I would put 15. Look at these buildings. Looks okay. And then if you, Hurricane Michael happened in October 2018. So this image was taken just a few weeks after the hurricane. This is how the buildings look like. So, and then in 2019, the buildings, they still damaged, not recovered. 2021, you see some of them got removed. So you keep tracking the recovery. One of them actually got recovered, like I believe like somebody's living there. And let's see the second one here. That one got recovered too. And let's see, another one got rebuilt. That's what we call tracking the recovery of the community. So that's a really, really good tool that we can track the recovery. And we can draw, if you guys remember our first lecture, the recovery curve, that's how we can track the recovery of the community. So how can I do this? You have to do it building by building. Go collect the data and see in 2015, 2018, what is the status? Fully damaged. 2019, partially recovered, like 50% recovered, 90% recovered, fully recovered. So, and then we put this into the GIS file for every building. So this is how we can collect the data. Some of this data might be provided like this. Some of this data, people would go to the site and take pictures, and these pictures are geocoded. And basically you can click on the picture and visualize how, like on every polygon, there is like a picture image, and you click the picture open and see the building, how it's look like, and do damage assessment and enter the data. Okay, so that's how we add shape files, create shape files, modify shape files. And I told you this is very, very important to be able to adjust the shape files. Okay, all right. So let's get back to the GIS again here. And I'm gonna stop editing, and I'm not gonna save what I did, so we don't mess with the shapefile. Do you want to save the edits? No. And I'm gonna open this back. Open the attribute table. So, all right, so let's say I have this data and I want to enter new data. Like here, I added this column and this column and this column. But what if I want to add a damage column? So all what I'm going to do is I'm going to do here something is called add field. When I add field, it's going to ask me, what's the name of this field? Let's actually add a field. It's called X longitude, or maybe we call it X longitude. And I'm gonna make it, it's gonna ask you, what is the type of this field? Do you wanna, it's gonna be short integer, long integer, float, double, text. So you tell him what he's expecting that you are entering this data, text or numbers. These numbers are long or short. So I'm gonna use double. Double is like really good that you can add a lot of numbers. And I'm gonna say, okay. So once I go all the way at the end, I will find my new field, the X longitude. So basically, there is some stuff that we can do in GIS that we can ask the GIS to do it for us, to do the calculation for us. And some stuff that the GIS can do. GIS don't know how much damage that this building has, so you have to enter it by yourself. But here, I might, since I have my buildings here and they are properly projected, I can ask the GIS, find the X longitude of this building. So you can come here on this column and then make something like this. It's called field calculator. In field calculator, you can put actually a number, like you can say that this X longitude is equal to the X longitude here. So it's gonna put them the same as, like if I click on this, I'm gonna say, I'm gonna find out, it's gonna take like a minute or something, and it's gonna put all the numbers that is in the other field. Or let's say there's some fields that requires the summations of other fields. Like let's say one field you have the ground elevation, and one field you have the water surface elevation. If you want to find the flood depths in the new field, so all what you have to do, you subtract the ground elevation from the water surface elevation so that you can get the difference. You put here some function. You say that this field is equal to water surface elevation minus ground elevation, and then you are going to get the flood depths. So here, this is the longitude. All right, so I might make this field, like I can go back to not field calculator. I'm gonna get back to something it's called calculate geometry. So when I say calculate geometry, so it has some feature. If you want to calculate area of the polygon, center of the polygon, or the X coordinate or the Y coordinate of the polygon. So I'm gonna say I want an X coordinate. So I'm gonna say here, calculate X coordinates, and then it's gonna say, do you want to calculate the coordinates in feet? You can calculate the coordinates in feet or miles or whatever you want. Why? Because you have a projection here. It's called the National American Datum or something that calculates it with feet. So if you use different coordinate system, oh, you can actually do it like, let's say this one, and you can do it as a decimal degrees, like the decimal degrees that you have here. So if you set decimal degrees and said okay, so it's gonna recalculate the X longitude, and the same thing with the Y latitude. It didn't change. It was the same numbers because the other one was calculated the same way. You can actually create a file like a field, like I can say add field, and let's say this field is equal to area. I'm gonna call it area 1, and I'm gonna make it maybe double 2. Okay. And there's a new field here, and then I'm gonna say calculate geometry, and I'm asked to calculate area. And the area can be in feet square. If you want them in different units, you can check the units that you want. Like if I wanted them in a square meters, I'm gonna put square meters, and then it's gonna take some time to do the calculations. Does anybody have any questions on the shape files? Is it interesting, this stuff? That's good.
I have a question.
Yeah.
So you said the projections map is provided by the county?
Yeah, because when they do, like, there's actually every county has a projection that works for them. And there's some counties, and like there's some parts inside the county that has like the projection is gonna have like NAD, and they have S1 that works for this county, or S2 or SS3. But there's some like regularity that we use WGS, it's called the World Geographic System, and there's something it's called NAD. So we either swap between these two, the National American Datum or the WGS, NAD or WGS.
If I have to work on something doing with Miami, where would I get this map?
But for what, like the buildings?
Yes.
So there's lots of data sources out there, okay? But right now there's, like I told you, there's the Microsoft building footprint. This is only gonna get you the footprint. So that's one way to do it. And there's
So what
something.
have the information inside the footprint?
No, but if you want something that has information for the building for the entire US, there is something is called the National Structure Inventory. You will come here, National Structure Inventory. That's a database for all the building in the US developed by the Army Corps of Engineers. Okay, so then you will come here. All right, I'm gonna go back. I'm gonna click this one, the Army National Structure Inventory. And here I'm gonna put documentary. All right, so basically if you come to the National Structure Inventory map viewer from the Army Corps of Engineer and you click on Florida and you will download a file that is like 2 GB or 3 GB. It's all the buildings data for the entire state of Florida. Okay, so that's one way to do it. So for me, when I get a data, before actually this website is new, like maybe 3 years ago. Before this, it was a lot of struggle to get data. But you can access I believe every county in the US, they have their own GIS hub. Like let's say I'm gonna search Miami-Dade GIS hub. Yeah, Open Data Hub. They have something, it's called something hub. So when you get there, they will have a lot of data, maybe more than the National Structure Inventory. So you will get here and explore all data sets. And then maybe we'll search for buildings or building permits, small building, large buildings, building footprint 2D, this one. And then that's gonna be completely different data. They will have some way to visualize it here to see where's the building look like or where's the area that we're looking at. And then you can download this data and it's gonna ask you how you want the data, as a CSV or shapefile. It's better to get them as a shapefile, but I'm gonna show you how, if you have the data in CSV, how you can convert them into shapefile. So that's also one way. So I believe every county in the US have their own GIS hub, and you can download this data, and it's much more, I believe, detailed, more than the National Structure Inventory, but whatever that works for you. Okay, so sure.
You said you would have to manually assess the damage of individual building in case of a disaster.
Yeah.
So doing that for a community would take forever. How do you do that?
So like okay, let me tell you, like something happened recently let's start with Mexico Beach. Mexico Beach, it was like around 1,200 buildings, but the damage, or most of the damage, happened for 400 buildings. So we were like 3 researchers, we divide everyone, take 100, and we finish them. That's small communities. Bigger communities, the much bigger team. Like, let me tell you, Fort Myers Beach, when it got hit with Hurricane Ian in 2022, Oregon State University hired, I believe, 30 or 45 students, and they led the students through the damage assessment. They trained them how to do damage assessment from the visual images, and they finished the data. And to confirm that quality, they hired experts to do some samples of the data to see how was the student samples matching the expert sample. So this is ways to do it. Currently, there's some research that use machine learning and image recognition that, like after Hurricane Ian, many universities got deployed, and I also was deployed in Fort Myers. We basically put cameras on top of the cars, and you drive in the street, and the cameras catches 360 of the street. And basically, you have a good visuals of the damage from the cameras. And some people would use these visuals, and that's actually what we did was Oregon State. Like we would do it manually, and there's some researchers they use a machine learning algorithms to do this damage assessment with a machine learning based on image processing. Like you train that, like you have a sample of the buildings, and you tell, like rather than doing the 35,000 building, you do 500. And you tell the machine learning algorithm, this building, because of this damage and this damage and this damage, is damaged to state 2, and this building is damaged to state 1. Or this door is damaged, this door is not damaged. So you trained it very well. Once you train it, you give it the rest of the data. Once you give it the rest of the data, it's gonna do the damage assessment based on the data he has. The more that you train it, the more he's gonna give you better damage assessment. All right? All right, sure. So okay, so let's say usually when we do analysis, like right now, okay, let me zoom to this layer. This is all the buildings. I'm not gonna load the base map because it's gonna take a lot of time. I don't know, when I do it at home, it doesn't take that much time, maybe the internet. Okay, so the thing is, when I do analysis or I want to do processing on this shape file, I don't use the polygons. I always use the points. And each building, there's a point in the center, and that's where the building is, and that's where I do all my damage analysis and everything on this point. So how can we convert these polygons to points? Here where it comes the arc toolbox. Look here. Oh, let me move this a little bit down. On the left here, there's something that's called the arc toolbox. If you don't have it, like once you install the software, you might not have it. So you are gonna have it here. Like if you click on this one, it's gonna take, I believe, 1 or 2 minutes until it loads. And then it's gonna open. Once it opens, I always put this tab on the side. Why? Because I use it all the time. So rather than every time I have to click on the arc toolbox, it's always on the left. I can click on it and do my analysis. Once you open it, it's gonna be something like this. Let's say, and how can I move it? Okay, so once you open it, I believe you can drag it. Like I'm trying to take it out, but it doesn't. But once I take it, there's something here to say auto hide or something. So you basically, if you did this and this, they are gonna be somewhere here. So basically you can click on them if you need them. Search, arc toolbox, whatever. Okay, so this is the toolbox that we have. And if you need some extra tools that is not showing here, you can go to customize, toolbars, customize and extensions, and you can add the toolbox extensions that you need. Like you need a spatial analyst tool. There's actually some tools for evacuation. It's called evacuation analyst, or flood information tool, or geostatistical tool, or hurricane tool. Actually, some of these tools wasn't there a few years ago. I just read them for the first time. Like if a hurricane tool that wasn't there. So maybe they developed these new tools. I don't know about them. I have to go and search what they have. Like maybe let's put the hurricane tool and let's see what is inside it. So once I close and open the arc toolbox, let's see where's hurricane here. Okay, guys, see, it's not here, right? Add in manager, not this one. Okay, there's network analyst and there is, let's put the flood information. Somehow it's not here. Flood information, space-time pattern. Maybe it's inside one of the tools, but once you click, the tools should show up here. All right, so let's see that we already have the tools. But the thing is, every tools has a lot of subtools. Like, let's see. If you go, for example, to data management tools, you will find something about archiving, attaching, graphs, a lot of stuff, photos, projections, like if you want to change projection. If it's raster, we are going to talk about rasters. If you want to project, define projections, there is a lot of stuff that you can do here. But the thing is, I don't know all of these stuff, and I want to do something, and I know some keywords. Like I want to convert these polygons to points. So what I would say is, I would say feature to point. And I'm going to search, click search. So a lot of stuff is going to show up. All this is stuff from different tools. So maybe you only hit points. You are going to see everything that you can do on the point, or you set feature because the polygon is a feature. So you write features and everything is going to show up what you want to do on this feature. So what I want to do right now, I want to convert these features to points. So what I'm going to do, I'm going to click on this. And actually it tells you here where is it exactly. You go to the toolbox system and then data management tool and then feature and feature to point. Like if you want to do it here, you will go to data management tool and then you'll look for features and then you will find something feature to point. So that's if you know where exactly it is, but let's assume that you don't know where it is. You just search whatever you want to do. Like you search the same way that I searched, click here, it's gonna open a box that you put the polygon shapefile like this. It says, give me the input shapefile that you want to convert. I'm gonna drag it here. And then it's going to tell you, I'm going to develop a new shapefile. I'm going to put it here. You can change the location where he want to export this file, or you can accept where he's going to do. I usually make all my shapefiles in one folder and I choose this folder and put the shapefile on so that I can know where's my files are going. And then I'm going to hit OK. So it's going to take some time. So I'm going to tell you what is the percentage. By the way, if this box didn't show up, because sometimes some ArcGIS versions, they make this stuff behind the scene. They would show you here the processing, how it's progressing. So here, can you see what happened? The polygons is there, and every polygon has a point in the middle. So if I zoom in, maybe here. And every polygon got a point. So, all right, guys, tell me what happened here. Why here there's a point that doesn't have a polygon?
Centered on the polygon
Exactly.
combined.
Excellent. So this is like a U section, and it's all connected. Okay. So basically, that's what happens is he made the centroid of each polygon and put the point inside this polygon. Sometimes, if you have the building is like a U shape or an L shape, the centroid is outside the shape itself. Okay, so that sometimes happens. Okay, so if I open this building polygons, so I'm gonna open attribute table, you'll find all the data that was inside the polygon is still inside the points. Is that clear? Okay, so the next that I want to do right now is how can I load files that are CSV? Like let's say I'm gonna open an Excel file. But before I do this, I want to introduce you to new types of data. So usually the data, the GIS process, it's always in two shapes or two types. We introduce the shape files. Shape files handle discrete data. Discrete data, the data that are not continuous. Every data is like a single point or a single polygon. They are not continuous. There's some data that are continuous, like maps, like a flood hazard map. A flood hazard map is all connected because the flood doesn't happen as a drops. So all water and this water is connected. Or an earthquake map. The earthquake affected the whole area, so it's continuous. So most of the hazard maps are continuous data. So discrete data are represented by shapefiles. Continuous data are represented by what we call raster maps. So let's see how the raster maps look like. So it's gonna be, let's go here at raster files. And it's not like the shapefile many files, it's only one file. So these are raster maps for Hurricane Ike that hit Galveston County in 2005, I guess. And I have a raster map of the maximum flood depths here. So basically, I drag this map and I go to the ArcGIS here, and I drop this data here. It tell me about the projections. So, okay, and then I'm gonna say zoom to the layer. That's how the raster map look like. So what I'm gonna do, I'm gonna remove these two layers and only focus on the raster map, and then I'm gonna put the base map again. Let me activate the base map. See if it's gonna take a lot of time. Okay, so this is the base map. Let me load this. That's how the hazard map look like. By the way, this hazard map is an output from a coastal analysis, and it's basically focused on the Galveston area. That's why you will see it's not extended here, not extended here, and only on the shoreline. Why? Because the flood didn't happen beyond this area. It happened here, but I'm not interested. It didn't happen here because the coast got flooded at this area. So this is a white and black. If you want to convert the colors, you can actually right click on this and go to properties. And once you go to the properties of this raster map, you can change the color. Like if you wanna, you go to something it's called symbology. And this symbology, you can pick the colors. Like if you wanna pick the colors like blue and say apply. So this map is gonna turn out to like the blue colors that you can see here. So if you see here, you will find that the dark blue, that means the highest flood depths. It's like 5 meters. The one that is light blue is 0. There's no flooding. So if we zoom at our area here, you'll see, maybe I can put the polygons back. And this is where you are gonna see, it's gonna take a lot of time to do this zoom. All right, all right, here. Okay, so what you can see here, like why here there's a box that is light blue and more lighter blue and more darker blue. Do you know what is these boxes?
The resolution of
Yeah, that's called the pixel. So any image that you have, it has pixel. And the smaller the pixel, the high resolution the map has. So the pixel here sounds like it's big, like really, really big. Like 1 pixel have like a complete block. So it might be like, I don't know, like 100-meter by 100-meter pixel. So it's really big. So that means like the quality of this map is not that huge. That means like definitely not all these buildings have the same flood depths. But this is the maximum that the coastal engineers can do, because when they run the maps for the entire Gulf of Mexico or the entire Gulf of America, right? So they run the maps around this entire big region. So so yeah, I mean, like if we need much higher resolution, so the pixel size are gonna get less and less. All right, so this is an example of the raster maps, okay? So right now we know that we have 2 types of data, shapefiles and rasters. The shapefiles are for discrete data, the raster files is for continuous data. So let's say that I have an Excel file, not a shapefile and not a raster map, like something like this. It's called 2018 Hurricane Michael Wind Grid. And when I open this file, it's gonna open something like this. Basically, this file give me the wind speed at specific locations. It give me latitude, longitude, time, and the center, the RMW miles. Oh, that's not the file that we need. Let's close this one. Not that, we need the wind grid. All right, this one. This one basically, let me zoom in. It gave me the latitude, longitude, and the wind speed. It's called the gust wind speed and the sustained wind speed. Okay. So the gust wind speed is the 3-second gust wind speed. It's average every 3 seconds. The sustained wind speed, the wind that happen over a long time. So that's why it's like a little bit less than the gust wind speed. All right. So we have the gust wind speed, and that's the one that we do structural analysis with, not the sustained. That's 3-second gust wind speed. You guys tell me, is that this is a hazard map, right? For the wind. But what format that we are giving this hazard map in? Is it a discrete format or a continuous format? Discrete, right? Because it's at a single point, it's not continuous. So let's see how we can convert this map from a discrete version to a continuous version. There's a way that we can do it. All right, so let's see. First, I have to load this map to GIS, but I need to make sure that this map is saved as a CSV file, because the only Excel format that our hazard map can read is CSV comma files, the comma delimited files. So I'm gonna say save, and I'm gonna say 1. And I'm gonna get back to the GIS. And I'm gonna go to file, and in file there's something that's called add data, and here you will find something that's called add XY data. I'm gonna add XY data, and I'm gonna click where my file is. So what I'm gonna do, I'm gonna go to home, folders connection. All right, so the thing is you have to connect to the folder that you want to. So if you wanna, all the folders that you have in your computer is not gonna show up. To show them up, you need to connect them. When you connect, it's gonna open a window, and you ask that I want to connect to file C or file D. So once you connect, it's gonna show up here. And here I have my files somewhere. Lecture 9. And I'm gonna see the CSV files here, and this is the one that I just created. I'm gonna add. So basically, actually, it catch the field that has longitude and put it in X field and Y field in latitude. By the way, if you name this field different names, you have to do them by yourself. But here he did it for you. He found that there's a field name in the Excel file. It's called longitude, and put it in X field, and another field lat and put it in Y field. Like if we go back to the Excel file, here there's a field is called lat and launch. So you already have them here. I don't have any Z field. And I'm gonna, if you want to define the projection, you can edit it or you can keep the same projection. And I'm gonna say, okay. It says that the table you specified doesn't have an object ID. GIS always need to add for each point something called object ID, number 1, 2, 3. I'm still gonna say, okay, add object ID. So the data is gonna be loaded as a points, and it's still gonna be like not a shape file. It's still gonna be as a CSV. So this is the data. You cannot see them because this Hurricane Michael happened in Mexico Beach, Florida. Right now, we are on Texas. So if you want to go there, you have to zoom to the layer. All right. I think this data is not projected. So the way that I know what projection that I'm on right now, I basically go to like I click on this, right click, properties, and then you will find something is called source. And in source, I can scroll down so I can read what projections do I have here. So the coordinate system that I have is WGS. So I'm gonna delete this for now. Like let's delete, remove. And I'm gonna do the same thing again, file, add data, XY data. And I'm gonna choose the file. All right, let's do, I'm gonna edit the projection and make it as WGS projection. Like, let's change the projection to this one. And I'm gonna say, okay. I'm gonna zoom in, click on this. And then I'm gonna say zoom to the layer. All right, so right now, sounds like it's loaded. You can see when I zoom to the layer, shows you where all the wind speed records on the entire, not only the state of Florida, the whole part that got exposed to the hurricane track. And what happened when I loaded this data? You guys remember, it gave me a message that this data is projected on a different projection, which is NAD, the National American Data. And the data that we have here from this one is projected on WGS, the World Geodetic whatever. And when I loaded this data, it completely loaded in completely different areas. So I reloaded the data and it changed the projection. So it got loaded at the same location. All right. What I got here is the data as points. Like if I make a close-up view on Mexico Beach, I believe it's somewhere here. So this data, you will find it's like a mesh, like rectangles, and this is the corners of the rectangles. So there is something, it's called feature, I believe, to raster. And if you see, they have the mesh is small at the shown line, and they make it bigger once you go inside. So what I'm gonna do is, I'm gonna come here. I don't know what tool I'm gonna use to convert it to raster. Like, I don't know what is the name, but let's search. Let's search feature to raster. Yeah, there's a tool, it's called feature to raster. I'm gonna click on this tool, and I'm going to load the input feature, and it's gonna ask me what field that you wanna rasterize. The thing is, the Excel file has latitude, longitude, gust wind speed, sustained wind speed. It's telling me what is the final output that you want to present on the map. You want to present the gust wind speed or the sustained wind speed. Like when you click on any point in the map, what do you want to show? Because the map is gonna only show one value. So I'm gonna tell here, I want the value to be the gust wind speed. VG was mile per hour. And put the data and the cell size, keep it the same as is. And I'm gonna say, okay, it's gonna take a little bit of time until it rasterizes this map. So let's see what happened. Complete. All right, so this is the raster map. Let's zoom on the raster map. Let me close the shapefile here. And I'm going to zoom to this layer. Okay, can you guys see how's the wind speed look like? Can you guys tell where's the hurricane track from this map?
Southwest, northeast.
Here, that means this is the ground zero where it makes landfall. And where's the wind is directed at the darker yellow. So this is where the hurricane passed, and all the light yellow that has the less wind speed, because this is the 145 miles happened here. And the more it progress inland, the wind speed gets less and less until it escape out of land. All right. So can you guys see how we converted? First, how we converted CSV file to shapefile by loading XY, and how we can convert the shapefile to a raster map. So and then we finally have something like this for Hurricane Michael. But let's actually zoom in. I'm not sure if I have shape files for this part, but believe I have the track. Here, I believe the track is like, okay, let's see. Let's load this map. It has latitude and longitude. I'm gonna load this here. File, XY. And I'm gonna load this one, the Hurricane Michael track. I'm gonna say add. It put the latitude and longitude. I'm gonna change the projection to WGS, World Geodetic System. And I'm gonna say okay, create.
How many Excel file can you load all in a one?
You can load whatever you want. Like, I just wanna see here, zoom to the layer. I believe it's loaded somewhere else. Like you see here, the data is loaded in okay, so the data is loaded somewhere else. Let's see what the projection that we have here. Should be WGS. Okay, let's do something. I'm gonna remove this again. Let's see. I'm gonna say file, add data, XY data. Okay, let's see if we put it with the same. So the tracks is right, but sounds like the projection is not right. So the thing is, let's try if we can project this data and it's gonna work. Like let's say I can come here and there is something is called projections, and there's something it's called project. I'm gonna put this here. It says that the projection is NAD, so we need the output projection to match, for example, the WGS. If I said okay, and it didn't change much. Something wrong here. Anyway, we are running out of time, but maybe there's something wrong with the Excel file. But I'm gonna try one last thing. Okay, plain Texas. Didn't change. Anyway, maybe we will not need the track for now, but what I'm gonna do, I'm gonna send you guys the data that I did for um Galveston and the data that I used to develop this WAN file, and our homework is gonna be to do the same thing that I did. Convert the shapefile from polygon points for Galveston County. And for Mexico Beach or for Hurricane Michael, I'm gonna give you the shapefile, and you try to convert the shapefile to from the CSV or the Excel file to shapefile, and from shapefile to raster map. Okay. So I'm gonna send the homework today. If you have any question related to the exam, I have the exam sheet here.
I have a class like in 15 minutes and 10 minutes actually. So maybe after the class, like around 12:30, you can, we can talk about the exam, right? Thank you.